Welcome to another edition of Math for No Reason. In this edition, we will try to address this interesting question, that is, how to identify rational numbers that have terminating decimal expansion. By terminating decimal expansion, we mean an expansion which stops after a time, say for example that of 1 by 4, which is 0.25, or 2 by 5, which is 0.4, or 3 by 20, which is 0.15. Now, how do you identify just by seeing a fraction p by q, which is in reduced form, that is, it is a rational number, that it would have a terminating decimal expansion. Now, observe that if you have a terminating decimal expansion, like here, you can write 1 by 4 as 25 by 100 or 25 by 10 square. Similarly, if you are looking at 2 by 5, then you can write 2 by 5 as 4 by 10, or 3 by 20 as 15 by 100, which is 15 by 10 square. Any number which has a terminating decimal expansion would be possible to write that as capital N by 10 to the power k, where capital N is an integer. Now since p by q is in the reduced form, so we can conclude that both n and 10 to the power k would have a common factor. So let R be the largest number that divides both capital N and 10 to the power k. That means so n divided by R is p, and 10 to the power k divided by R is q. Therefore, we see that R is equal to 10 to the power k by q, which means that q divides 10 to the power k. Now, 10 to the power k can be written as 2 to the power k into 5 to the power k. And if q divides 10 to the power k, then q must be of the form 2 to the power m into 5 to the power n, where both m and n would lie between 0 and k. Thus, if q is of the form 2 to the power n into 5 to the power n, then only it would be possible to have a terminating decimal expansion of a rational number. Thus, we can say that if a rational number has a terminating decimal expansion, then q must be of the form 2 to the power m into 5 to the power n. Now, let us see if the converse is true. Now, suppose q is equal to 2 to the power m into 5 to the power n, and we are looking at p by q, which is p divided by 2 to the power m into 5 to the power n. So, let us look at three cases. So, if m is equal to n, then we have p by q is equal to p by 10 to the power n, and since p is an integer, this has a finite decimal expansion. If m is greater than n, then we write p by q as p by 2 to the power m into 5 to the power m, and the numerator is an integer and the denominator is 10 to the power m. So, we again have a finite decimal expansion. If m is less than n, we can write p by q as p into 2 to the power n minus m divided by 2 to the power n into 5 to the power n, and this would become some other integer m divided by 10 to the power n, and this again gives us a finite decimal expansion. Thus, we have shown that if a rational number has a terminating decimal expansion, then q must be of the form 2 to the power n into 5 to the power n. Thus, p by q has a finite decimal expansion if and only if q is of the form 2 to the power n into 5 to the power n. This is a good place to stop. Thank you.